Today we're going to be looking at 1.2, where we are going to see Venn diagrams, universal set, and complement of a set. Okay, so we're trying to understand how a Venn diagram actually works. So yesterday when we saw and understood sets, right? Okay, it is basically mainly about notations. Okay, saying how we can actually simplify, right, or we want to describe certain things. Okay, using some notations. For Venn diagrams, it is going to be a pictorial representation. Okay, so basic Venn diagram, okay, could look something like that. So usually we will have a rectangular box. Okay, on the outside I will label is this symbol here. Okay, how it is being written is an E with a tail at the end. Okay, so it's just an E with a tail now, right? With a hair on top and then a tail at the bottom. Okay. Then after that, we will have circles. So as an example, I will have it this way. Okay, so what the rectangle represents, it represents a set of all elements. Okay, they are under consideration. So for example, if you're looking at all the numbers from 1 to 5, okay, we will use the rectangle to actually create a border around it. Okay, it is what we call a universal set. Okay, and we denote it with the symbol, I don't know what is this thing called. Okay, we'll denote it with this symbol. Right, then circle, it basically represents the different sets that we can have, right, in the universal set itself. Sometimes we can have more than one circle, alright. If you ask me why is it that there isn't one circle for 4 and 5, okay, that is also possible. It just depends on the question itself, okay. So in this case, I have my set A, okay, where I label it A, and then after that near the circle, okay, to represent that group of numbers 1, 2, and 3. Okay, if you're just trying to draw the circle to exclude, okay, certain things, alright, so this is what is happening. If I define A to be the set containing 1, 2, and 3, we are excluding 4 and 5, which is found in the universal set. Okay, so the 4 and 5 is what we call the complement, okay, of set A. Okay, so complement in this spelling, alright, and this refers to the elements. Refers to the set of all elements in the universal set but not in the set A. So in this case, when we want to describe the complement set, we will put an A with kind of like apostrophe, okay, on top right hand corner of the letter A. Okay. So with this, what I'm trying to say is that I need to introduce to you a universal set, okay, how we use circles and also rectangle to actually draw our Venn diagrams, and then also about the complement, which are is the set of all the elements that are not in A. Okay. Any questions up to here? Questions? Okay, so something that I need to point out to you is that when it comes to drawing a Venn diagram, okay, and when we label, okay, when we put in the numbers and all that, okay, sometimes it could be numbers, sometimes it could be words, right? Depends on what we're trying to describe over here. Okay, the elements that we put inside the Venn diagram should not be separated by commas. So I cannot, okay, write things like 1, 2, 3, and then after I put 4, 5. Right? I cannot actually write my Venn diagram in this manner. It needs to be loosely placed. Okay, that is just a design of the Venn diagram. Okay, so notice that just now I was loosely place it around like that. Okay, and then 4 and 5, you can put your 4 here, you can put your 5 here, that's fine. Because it's still, we can see that it is outside of that circle, meaning to say that it is a complement, okay, of that set A. Right? So no commas found inside the Venn diagram itself. Okay? Then something to also be wary of is that because you're going to loosely place it around, it's important that there is sufficient space between all your numbers. Okay? You cannot put it so close such that it may end up looking like you're talking about 123. Yeah. So do draw it sufficiently big, okay, when you are drawing a Venn diagram, and then after that loosely place your elements around it. Okay? Then after that, you need to label, you write the elements all inside, okay, the circle or the rectangle itself. But when it comes to labeling of the set and the universal set symbol itself, okay, you need to put it outside the borders or the outline, okay, of that set. Okay, so elements inside, labeling outside. Understand what I'm saying? Okay. So let's look at an example. So in practice now 3, we are given that the universal set is being defined as containing all the integers between 1 and 13 inclusive. And then for B, okay, it is the set containing the prime numbers. We want to first list out all the elements. So could you take 1 minute to actually list out all the elements in the universal set and also in B, okay, using set notation. You can't draw up. You see, like that, like that, like that, like that. You try. You need to practice it, okay? I think those that do a lot of calligraphy, okay, with your brush pen and all that, okay, you may find this easy. It takes practice. So what are the elements inside the universal set? Answer, what do you have? First number? Sorry? 1, okay, all the way till 13. Okay, then what about in the set B? Noi? What? 1, 2?
1, 2, 3, 4.
7, 9, 11, 13. Sorry? 1 is not? 9 is not okay. Any other corrections to make? No? Anybody agrees, disagree? Dylan says 1 is not. Okay, so Noi, what do you think? Is 1 a prime number? No, okay, so 1 is not a prime number, okay, because the definition of a prime number is that it has exactly 2 factors. And the factors are 1 and itself. So for the number 1, it has only 1 factor because it's 1 times 1. Okay, so 1 and itself is both the same, so it's only 1 factor. Sorry? Sorry, I can't hear you. Oh, okay, good question. Okay, so Joseph asked, right, for this list of prime numbers, okay, why is it that we stop at 13? Shouldn't it endlessly go on? Right? That's your question, right? Okay, so to explain this question, I think it's a very valid one. Why is it that we stop at 13? Okay, it's because, right, in this question, there is a boundary being set already about the universal set. Okay, so your boundary is being set, limited by the numbers from 1 to 13. So whatever subsequent sets that we're referring to, okay, is going to be bounded by the universal set. Okay, so that's why it doesn't go on endlessly, right? So it will only stop at 13. Okay? Alright, good question. Okay, so next, okay, part 2, draw a Venn diagram to represent this. Okay, so if you understand what I've written, okay, maybe 1 minute, right? Try to draw your own Venn diagram, okay, with the elements that we have already stated out. By the way, for rectangle, please use ruler. Some of you draw it quite small. Feel free to draw it bigger, okay? In the exam, I'm sure you get a lot of space. I hope that you're drawing small because you just want to limit it to your notebook itself. Okay? our Venn diagram, okay, we should have a rectangle with the universal set symbol placed on the corner. Okay, my habit is to always place it on the top left corner lah. I think typically when you read any books itself, they always label it on the top left hand corner. Okay, then after that we will draw the set B, since we only have one set in our discussion. And now we put in the numbers. It's easier to put in the numbers for B first, since you already listed them out. Okay, so we should have 2, 3, 5, 7, 11, 13. Then, okay, those that are not found inside B, you have to put it outside. So that will be 1, 4, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12. Okay, you can definitely put it around. Okay, that's fine. Okay, so not an issue at all. As long as your elements are clearly listed out and it is obvious that you're writing 10 and not 910. Okay, so that will be your Venn diagram. Any questions? Right, next we look at part 3. So from the Venn diagram, it wants you to list out all the elements of B prime in set notation. The usefulness of a Venn diagram is that you can see very clearly what is going to be in a Venn diagram, what's going to be what's going to be in the set and what's not going to be in the set. So in the complement set itself, we are going to have the elements 1, 4, 6, 8, 9, 10, and 12. Okay, now for part 4, how do you want to describe this complement set in words? In words means there shouldn't be any symbols, no notations at all. How to describe? What do you think? How will you describe B prime?
The elements in set B prime are numbers from 1 to 13 that are not prime numbers.
Okay, so Katja says that the elements in B prime, okay, let me use your words. The elements in B prime are the numbers. You said the numbers, right? From 1 to 13 that are not prime. Okay? You said that, right? Okay. Anybody else thinks differently or feel that something is not right? No? You all can accept this answer? That the elements in B prime are the numbers from 1 to 13, since you're talking about 1 to 13, that are not prime. Yes? Okay, the elements in the set B prime. In the set B prime. Because B prime is a notation for the set, it's a set already. If you want to include that, saying that it's a set, that's fine. The elements in the set B prime are the numbers. Anybody else want to add? Can you go? Yes, Chen. Sorry? Inclusive. I can't hear you. Inclusive. Is that what you said? Okay. So from 1 to 13 inclusive. Okay, sure. Anything else? No? We find this definition? Okay. Alright, I want to point out a certain thing to you. I know that we all recognize all this as numbers. Okay. But it is not correct to actually use the word numbers itself over here. Okay. Why is that so? When we say numbers, it can include things like your integers, it can include your decimals, it can also include your fractions. You can include your irrational, it can also include your rational numbers. So when you actually use the word numbers so loosely like this, okay, and you say that they are not prime, that means that in my B prime, I can have elements such as square root 2 because it is a number. I can also have numbers such as maybe 2/3. It is not prime and it is a number also. So there is an issue over here when you use the word numbers. So then what should we use? We should use the word integers, okay? So we got to be very careful in the terms that we use, okay? I know that everything is a number to you, alright, but then you need to try to think, is there something more specific, folks? Is there something more specific that you're trying to refer to? Okay? Okay, so in the words that just now previously earlier and also Zhen Quan added on, I think that's fine. It makes the whole definition slightly more fuller. Okay, although technically even writing this inclusive, it doesn't actually affect anything because 1 and 13 they are already prime numbers, so naturally they are not going to be found in B prime. So it doesn't affect how B prime, the elements in B prime are going to be. Okay, so there is some consistency in this. Okay. Another term, okay? I want to introduce to you this word called proper subsets, okay? I think maybe some of you have come across this word before, subset, when you want to say that this class is maybe a subset of the school, okay? So that means you're part of the school, okay? So that's what the meaning subset actually means. But there is a more proper definition when it comes to mathematics, okay? So when it comes to proper subsets, okay? So for instance, alright, if I talk about the set A to be containing elements from containing elements 1, 2, 3, 4, 5, and then the set B 1, 2, and 3, okay, we find that B is completely inside A. So if I want to draw a Venn diagram, recognize that A and B, none of them are actually universal sets. The symbols is just A and B, so we will be drawing circles instead. So we have A to be the bigger one since it contains more elements. B will be inside, okay, because 1, 2, and 3 is the overlap. It is in common between the two sets, okay, and then 4 and 5 to be outside of B, but yet inside of A. Okay, so we see that B is completely inside A. So that means that every element of B is an element of A. Okay. Furthermore, maybe I don't put brackets. Okay. Other than the fact that every element of B is an element of A, we also recognize that A and B are not equal. They are not equal sets, okay? So they are not. They are just one inside another. So in such a case, we call this a proper subset. So when B is a proper subset of A, we use the symbol B. This symbol itself is like an elongated C, okay, slightly flatter. and then this symbol will represent B is a proper subset of A. Okay. So next, other than talking about proper subset, I need you to also recognize the difference between proper subset and subsets. So when we say that B is a subset of A, the meaning of subset is that B could be a could be a proper subset, or there is that chance that B is equals to A. Okay, so subset is a broader definition, whereas proper subset really restricts it such that it is only a part of. Okay? So we need to be familiar with the words. Okay? So a subset is still a set itself. Okay, so we can say that B is a set of its own. Okay. Okay, so now let's look at practice now for questions regarding proper subsets and sets and subsets. We can carry answer here. Okay, so the idea of subset, right? Okay, is that there is that chance that it could be equal to. So for example, right? Let's talk about maybe this class. Okay, this class. If I create this class as one set itself, okay, a set of four students, okay, then it is obvious that if I have another set, okay, so let's say, okay, I just write it very loosely, okay, not a correct way of notation, okay, so A to be a set of four students, and then after that, I want B to be defined as a set containing all the girls. Okay, so in this class, we are fully aware that there are both boys and girls, right? So we see that B is definitely a proper subset of A. Agree? Okay, but what if, okay, the next year, okay, maybe the four students, alright, it's actually a whole class of girls. Okay, if I keep this definition, alright, and I apply it to next year, okay, that is whole class of girls, right? Then I will say that B, okay, the set containing all the girls, okay, is going to be a subset of A already, because there is that possibility that B is equals to A. You understand? So the definition actually changes, right? This situation actually changes according to what is it that we have. Okay, realistically, most of the time, okay, we will see that it is a proper subset rather than it is a subset. Okay, you understand what I'm saying? Okay, so are we having a clearer idea now? Okay. So subset is usually used when chance that they are equal or not. Okay, so if there's the uncertainty that you don't know, okay, that you don't really see all the elements yet, because there's sometimes questions are very vague, then you don't get to see every single element. Okay, so that is where you use the idea of subset. Okay, but if you're very clear of the elements, okay, that you have in the sets itself, then you can very clearly use the word proper subset. Okay. So now that we look at practice now 4, question 1, okay, for C and D, okay, they have the elements 1 to 7, and then for D 1, 3, 5, 7, we want to draw a Venn diagram to represent the sets. Alright, so maybe I give you a minute, okay, to draw how this Venn diagram will look like. Are we done? I noticed that some of you enjoying your Venn diagram. You drew it this way. Okay, then after that some of you drew it this way. So which is correct? Or are both correct? What do you think? Who thinks that this is fine? Okay, surely somebody in the class drew this, right? So now you're having self-doubt. Okay, so what about this one? Who thinks this is the correct one? Okay, so why is this the correct one then? Because see what? It's not a universal set, okay? So we will reserve the rectangle shape for universal sets, okay? So in this case, we shall draw the circle, okay, with another circle inside. Alright, so this will be the correct representation to draw for this case. Okay? Then in part 2, the question asked, is D a proper subset of C? Okay, so what do you think? Yes, no? Teresa? Yes, right? Okay, so D is a proper subset of C, but why? Because? Joshua, what do you think? Why is D a proper subset of C? Okay, every element of D is an element of C. Anything else? That will be your explanation. Okay, you get half a mark correct. Okay, half correct. Because when we talk about proper subset, the important criteria is also to know that they are not equal. So in your explanation, other than saying that every element of D is an element of C, okay, we need to also say that D is not equal to C. Right? Because we are clear about that D and C are not equal. Okay. Just now, sorry, to rewind a bit, okay, I realized I forgot to mention that for the notation of B is a subset of A. Okay, proper subset, we have this notation. For subset, right, we will have this notation. Okay, where it's just like your inequality sign, where sometimes we have the equal sign at the bottom, right? Okay, so we have this symbol for subset to actually denote that there is that possibility of being equal. Okay, so in question 2, we have this PQR sets. Okay, in part I, we want to list all the elements of P and Q. Okay, could you take a minute to actually write down the elements of P and of Q? So what are the elements in P, Nicole? 1 to 13, okay. Right? Anybody disagree? You good with this? These are elements? Okay, so you notice that x must be an integer, 0 and 13, 0 not inclusive, that's why start from 1 and then include 13. Okay? So then what about Q? X is a prime number less than 13. So what are the numbers that we should have? Joseph say 2, 3, 5, 7, 11. Agree? Anybody wants to put in 13? No, huh? Okay, because it is less than, so strictly no 13. Okay, so these are the elements of P and of Q. In part 2, the question is asking whether Q is a proper subset of P or is P a proper subset of Q. So what will your conclusion be? Okay, so Amanda? I didn't hear your answer. Yeah. Q is a proper subset of P. Okay, so Joseph also says the same thing. Okay, so Q is a proper subset of P, but why would that be the case? So explanation, Shami? Okay, very good. So the reason is because every element of Q is an element of P and Q is not equals to P. Okay? Next, part 3, listing all the elements of R. So same thing, give you a minute to write that down. Okay, so what are the elements in R? Jinya, what elements do you have in R? Starting from what number? Sorry, do you say something? What are the elements found in R? I can't hear you, I'm sorry. 1 to 13, okay, thank you. Okay, agree? Disagree? Should we have 13 inside? Yes, because not more than means that it's less than or equals to. Okay, so then after that, finally in part 4, it is asking, state the relationship between the sets R and P. Okay, so what kind of relationship would they have? Don't tell me their boyfriend, girlfriend is not correct. Okay, please. So what kind of relationship do they have?
They are the one and the same.
They are what?
They are same.
They are the same. They are subsets. So what is a subset of what?
P and R are subsets of each other.
How can they be subsets of each other? If they are subsets of each other, then wouldn't they be equal?
Yeah, they are equal.
So they are equal. Okay, so what you can say with the R and P. Hang on now. Why did I write this too? Zero, not more. Not more. Okay. Sorry, I think I must have written something wrong here. Okay, so R is equals to P. Okay, because all the elements in R are the elements in P. Okay, anybody wants to suggest something else? Would anybody want to say that P is a subset of R? Or R is a subset of P? Okay. Why would we want to say that? Because what? Because they are equal, okay? Technically, you can say that R is a subset of P and P is a subset of R. But since you're very clear that they are equal already, okay, then might as well just go ahead and say that they are equal sets instead. Okay, then you will be just less ambiguity and you're straighter and it shows that you are more clear about the relationship also. Yes. Yes. Okay. Okay, next we look at listing all the proper Okay, so what do we mean? Okay, it is that if I have the set 1, 2, can you tell me what are the proper subsets that we can generate out of this set itself? What are the proper subsets of S? Can you give me one set, one proper subset? Jared? Can you give me a proper subset? Tell me what is this element in the proper subset? Sorry? Empty set. Okay, that's very quick that you think of empty sets already. Okay, so yes, empty set is a proper subset of S. So if you think of S to be in this way, okay, we can have 1, 2. We can have another circle inside that is empty. So an empty set, in fact, is always a proper subset of any set. Okay, so we have that. What other proper subsets can we have? If I have S, 1, 2, how else can we draw this Venn diagram or segregate or divide the elements? Amanda? Circle the 1. Okay, so we can have a proper subset containing just 1 itself. Okay, and then also we can definitely also just circle the 2 where we have the set containing 1 element. Okay, so the proper subsets of S in this case will be the set containing 1, the set containing 2, as well as the empty set. Okay, so looking at page 12, there's a practice now question. I want us to list all the proper subsets of the set T as well as the set S. Okay, so could you take maybe 3 minutes, okay, to list out all the possible all the possible proper subsets. Okay, are we done? Alright. Anson, could you tell me what's the answer for part I? Sorry? Empty set. How do you write an empty set? Sorry? Just the curly brackets. Okay, then after that, what else? Set containing 7. And okay, set containing 8. Okay, I hope that no one actually gave me an empty set with the 0 inside. Okay, so yesterday I hope we have clarified that an empty set will not have any elements, and if you write a 0 inside, it suggests that there is a element, okay, which the element is 0. Okay, so you can denote your empty set in this manner, or you can use the symbol 5 over here. Okay, what about part 2, the proper subsets of T? Okay, could you give me one of the proper subset? Sing. Give me one proper subset. I'll give the easy one, empty. Okay, you give me the more difficult one. Yes. A, is it? Okay, a set containing A. Alright. I think there's many, right? Okay, so let's go down the row. Ying Ying, what's the next one? Set containing B. Wei Chan. Set containing C. And then Hoi Ying. Set containing A, B. Okay. What else? Ling Hui. AC containing AC. Okay. What else? Alia? BC. Oh, BC. Okay, set containing BC. Anything else? No more already? Okay. So that will be all, right, for the proper subsets of T. Okay. Now I want us to look at exercise 1B, question 8. Wait, our lesson at what time? 20, right? Okay, then never mind. I'll continue with this tomorrow then. Okay, so tomorrow remember your 1A is due.